I would like to introduce our presenters today. We have two speakers. The first one is Aleksandra Kovachev. She's a senior data scientist at Delivery Hero, one of the world's leading online food ordering and delivery marketplaces and a European startup unicorn. She has been in the field since 2016, and before that, she completed a PhD in computer science and engineering in Skopje with a focus on knowledge extraction from graphs. And our second presenter today is Varun Chitale. He works also in Delivery Hero as a data scientist together with Aleksandra in the recommendations and ranking team. He has extensive experience with NLP related topics and deep neural networks. So Aleksandra and Varun, thank you very much for being here today and for presenting your use case for all of us. Your turn, please.
Hi, Macarena. Thank you for the introduction, guys. I will now share my screen and start with the presentation. Is everyone seeing the screen? Okay. Is this good?
Yes, yes. I see it perfectly well.
Yeah. So thank you everyone joining us in this session. As Macarena presented, I'm Aleksandra and this is my colleague Varun. We are to present you today how Delivery Hero discovers where, when, and what our customers want. So, okay, yeah. I will start with some key facts about Delivery Hero. It was founded in 2011 by Nicholas Östberg, and today is one of the leading online food ordering and delivering marketplace, and we operate in over 40 countries. Every day we process millions of orders, partnering with over 600,000 restaurants, and we own a fantastic fleet of riders. But we don't stop with food, and we are really proud to be the pioneers in quick commerce, the new generation of e-commerce. Another milestone that we are really happy to announce is that we reached over 100 nationalities in our Berlin headquarters. This is a visual depiction of some of the brands we have around the whole globe. And you might recognize some like Pedidosia in the South Americas, Foodpanda in Asia, Talabat in MENA, and many more. But today we are here to talk about recommendations, and as a wise man once said, a lot of times people don't know what they want until you show it to them. And this is exactly where recommendations comes to play. So why are recommender systems useful? I don't yeah. Oh, it goes just forward? No, okay, sorry. Recommender systems are today widely employed in industry in order to present the customers what they can read, what they can buy, or what music and videos to watch. The recommender systems helps users to discover relevant items and deliver a delightful experience. They're alternative to search engines by providing and reducing the effort of searching and surprising the users with offers they never thought searching for. Recommender systems are the most powerful machine learning systems that online marketplaces implement in order to drive incremental revenue. And we all know that we almost always, when we listen music from like Amazon, Spotify, Netflix, we pick a lot of items that were recommended to us. Okay. So there are many definitions of the types of recommender systems, but this is one that I particularly like, where the first level we distinguish the recommender system, especially the personalized one, between the memory-based and model-based systems. The names said itself that the memory-based recommender systems apply a mathematical approach where which is non-parametric, and usually we compute some similarities between the users and the items using some heuristics. The second type of definitions, the model-based recommender systems, where we usually use some algorithm in order to predict the next item that the user will likely purchase or like. The most popular definition by recommender systems is the one based on the data we process. That is the content-based filtering and collaborative-based filtering recommender systems, and the combination of both the hybrid recommender systems. In the content-based filtering, we focus on the features of the content or the items the user interacts with, and we try to find similar items to recommend to our users. Whereas in the collaborative filtering systems, we don't focus on the items itself, but we focus on the other users, and we are trying to distinguish tastes of the other users and which are similar to our query user. Something that is also interesting to mention for the recommender systems as a machine learning algorithms is that they can use two types of user feedback of data, which is explicit and implicit. The explicit data is the one that we gather from users which are ordering something or rating, giving numbers of something, which is very important, but also very interesting is to analyze the implicit data we collect for our users, which is the interaction of the users with our content, like clicks or watches, which is not that always visible. Additionally, there is a challenge in recommender systems by evaluating our recommendations, because offline evaluation of recommender systems is sometimes very tricky, because our data, our training data, sometimes is already biased by the recommendations we show. That's why it's always better to use A/B testing for online evaluations, but this brings the cost of waiting for a particular time before we can compare some results. And ideally, we would like to balance, like we would offline evaluate the same algorithm but different parameters, for example, and do online evaluation when we want to try to compare two different approaches. So how we do recommendation at Delivery Hero? In God we trust and all others must bring data is a nice quote that sums up the main ingredient of all machine learning algorithms, data. So at Delivery Hero, the main single point of our data sources is the so-called data fridge, which collects and unifies and standardizes all the data that comes from different brands and different platforms. From there, we use the explicit data, like from orders, vendors, and products information and reviews. We also have tracking data from where we extract implicit information about our customer feedback, like clicks, page interactions, add to cart, and so on. We process and analyze this data to furthermore extract meaningful features for our recommender systems. As Delivery Hero grows and expands, we distinguish with different types and categories of recommendation in our team. So first, we distinguish between the vendor level recommendations and product level recommendations. Each of these levels has also different categories which define the type of the marketplace. For example, it can be restaurants, it can be supermarkets, or it can be shops like toys and pharmacy and so on. For each of these combinations of level and category, we provide recommendations starting from the most basic one, like past orders or popular, but also the personalized, like recommended for you, complimentary, and etc. Additionally, for each of these strategies, we can have different versions which we experiment with or upgrade and update and so on. And each of our consumers, which are our brands, can require for specific version or for specific combination from these strategies. So let's now dive deep in our architecture and technology stack that we use to produce and serve recommendations. We built our modules or our models mainly in Python and its libraries like TensorFlow, scikit-learn, and so on. We host our applications on GitHub, and usually we provide Docker images, which with merge on master branch are deployed to a container registry using Jenkins. These Docker images are then used by our scheduler, Airflow, and wrapped in the Kubernetes pod operators and executed. We have a use case where we are able to automatically generate tags in the Airflow only by using config files, where the config file specifies which parts of the models should be executed. For example, extract data, train model or preprocess, publish or recommendations or predictions, and so on. All of our recommendations are then exported to a Google BigQuery or Google Cloud Storage, which then are ingested by a Postgres database and used by our APIs. As you can see, we are using the Google Cloud as our platform. Our APIs are also built in Python in the Fast API framework, and because we have several use cases of APIs, as I mentioned, first the vendor and the products API, but also we are building like customer profiles API or ranking solutions API. We have a gateway API, which is able to serve and monitor and maintain the calls that we are getting from our consumers. For alerting, we are using Slack notifications for Airflow and for the API, and also Datadog for monitoring of the APIs. So before we go more into machine learning and data science, we can have some questions here, or we can continue. Yeah, I think we can continue. So I will give it to my colleague.
Hey. I'll be talking about one approach with which we can recommend items or vendors. When we say vendors, we usually mean restaurants or shops or stuff like that to customers. Now for that, basic introduction to collaborative filtering might be needed. Aleksandra already covered some part of it, but collaborative filtering works in a way wherein you analyze transactions or you let the users decide what they want. So there are two types of collaborative filtering approaches usually used. One is the customer-based and one would be the item-based. In the customer-based, you would analyze customer preferences while recommending items to each other, whereas for the item-based, you would analyze items as your main set and then recommend them to individual customers. Note that some of the recommendations might be different in these approaches. For example, over here, you can see that the cloud thingy is not recommended to the third customer. Why should you consider using collaborative filtering as opposed to, let's say, content-based recommendations? One major point of this is context independence. At Delivery Hero, we have so many brands and so much data flowing in and out that it is super difficult to maintain the quality of the data and to have all of the data and the domain knowledge extracted and stored in a useful way. So if we were to come up with a recommendation algorithm that is context independent and it does not care about what, care a lot about what is underlying, then it would be a beneficial thing to have. Second thing is that it is practical. To give you an example, let's say we could have a lot of users ordering, for example, toast and ice cream. You might say that this is not the ideal combination, or if you go into embeddings for toast and ice cream, they would be far away from each other. But just because we observe a trend, we are able to capture it using collaborative filtering. And which brings me to the third point, which is the trend evolution is captured. If you keep on retraining your models, or if you keep on improving the collaborative filtering, you would capture trend over time. Of course, it has some pitfalls, but there are some solutions to these. I'll just go through some of them. Cold start. Cold start would be if you have a new item or a new customer recommending this item to customers or recommending items to this customer would be difficult. For a new customer, a solution could be to use some other recommendation approach, like recommend the most popular items in the area. And when you do that, you actually take the entire population as your data generating source. Talking about sparsity, there are a few ways apart from getting, let's say, more traffic or having denser representations of underlying entities. For scalability, the problem here is that if you're able to somehow generate a latent space of embeddings of entities, then you are able to find similar items to recommend. But then you have to consider a large candidate set, and scaling this becomes a problem. So you could either intelligently reduce the set size or use libraries like Annoy that Spotify has for recommendations. Gray sheeps. Gray sheeps are basically customers with unusual preferences that sort of dilute the whole model. But and shilling attacks are, some owners of restaurants, or for example at Amazon, some owners of products push their products up by influencing reviews or order purchases and so on. So intelligent pre-processing would be a way to avoid all of these things. I'll talk about a use case that uses neural networks for generating these latent spaces that we talked about. Uh, as seen here, all models are wrong, but some are useful, or maybe parts of some models are useful. The basic idea for any problem related to recommendations would be to analyze a transaction. It could be any transaction, like an item click, a purchase, a swipe on an item, a removed from cart, or anything like that, because it would contain underlying dormant information. If you analyze a number of such transactions, if you pass them through a neural network, we should assume that it would be able to capture the relationships between these items, or be able to encode these in a latent space. And now this latent space can be used to model solutions for a lot of problems, including recommendations, search, and so on. So in the figure, you see a transaction where you have things like what the customer ordered, the billing details, the location, that would be the distance between the customer and the vendor, and so on. You would analyze this, you would put it through a model, you would generate recommendations, and you can also pass this back to your analysis step to further improve the central thing. So a simple representation of a neural network would be a concatenated transaction vector, wherein you can have, let's say, for example, I need to generate latent space for a customer and vendors. Then I would have a concatenated vector of customer, vendor, maybe the review that he posted, the order details, like was it a pickup, was there some discount that was currently running, some other analytics, and so on. I would then pass it through a neural net. Ideally, a converging kind of neural net would be ideal for this scenario. You can also have some bias inputs in the intermediate layers. You can also have multiple optimization functions. Okay, I skipped a slide, but that's fine. And in the end, choosing the right objective is important. One example of an objective would be, for us, we used, let's say, orders as our positive class and clicks that were not converted to orders as our negative class. And when we analyze the 4+ million orders that we have and a lot more clicks every day, the neural network was actually able to capture latent information for both customers and vendors. I would like to point out that the evaluation metrics that you use in recommendation tasks are different from your normal classification or regression tasks, because considering just precision or recall alone would not be a good metric. You should go for something like NDCG or ROC, AUC, and so on. And lastly, we talked about sparsity. One way to beat that problem would be to use something like a stacked XGBoost model, taking out these embeddings from the neural net, passing it to XGBoost, maybe optimizing it against another objective. And with this, you can also do it real time. The XGBoost model would serve recommendations real time. The features of XGBoost, everybody knows about the features of XGBoost. The previous architecture overview, this is a snapshot of that with some added information. In this, I would particularly like to talk about vendor embeddings. If you are able to generate a latent space for restaurants or shops or any kind of vendors, you automatically extend the scope of recommendations to some other fields like real-time recommendations. The Pinterest has a session-based recommendations wherein it analyzes what you've just clicked. And if you have embeddings for all the vendors, you can just show a list of vendors. Marketing vendors, similar vendors can be sent to users using push notifications and so on. Search applications, a good application would be, let's say someone searches for KFC, you find KFC as your top result, but then you also know that McDonald's is similar to KFC. And then you return a list when your search query was KFC, but you also managed to return McDonald's. Logistics for prep time models and so on. One last thing I would like to talk about is serving recommendations, the last part that you see in this slide. We have a Python API running fast API framework, which is really good in terms of async and await, because with machine learning models, you need a lot of time for processing the data, then actually predicting and returning results. We have a Kubernetes infrastructure which supports auto scaling, load balancing, and so on. And lastly, we monitor it in Datadog. Yeah, we also have some other data science projects in our team that use embeddings in some form or the other. Over to the right, you can see a latent space of products. We had a project wherein we categorized dishes or vendor products, and we came up with some domain information without using domain knowledge. Yeah.
Yeah.
I think I'll give it back.
Thank you. Yes, we have a growing team, so we have open positions. Please check out careersdeliveryhero.com, our recommendations and ranking team in the Discovery and Search squad. If anyone has found this presentation interesting, please also reach out to us. This is the winning team, the best team that is responsible for all the work. It was baked during COVID time, so it is really also a new team, and we are happy that we were able to present our work here. Yeah.
Well, thank you very much, Aleksandra and Varun. We are waiting for questions. I have some in the meantime for you. Exactly that. I mean, you just presented your team, which is really great and multinational, as you mentioned. And you are, I mean, the team who handles data from all over the world, because you mentioned you have customers. So how do you handle that? I mean, this location, let's say, because I can imagine that maybe clients from different countries have different behaviors or different, there are different trends or different things are in fashion in different countries, or they have different needs. How do you take that into account?
Yes,
you select features?
Exactly. I mean, the features are the same or similar, but building the model is specific for a particular country or a region. And we also observe that different countries, depends also on density, on the population, they have also different different behavior. Just for example,
Really?
say, yeah, for example, we, even for the popular restaurants or products, like for Singapore, the distribution of popularity is completely different based, for example, for Taiwan or Malaysia, although they are also in the same region. But we also need to be careful of and have this information at hand.
That's super interesting. Well, we have a question there. Thank you for the interesting talk. And they said, do you see any attention-based models for recommendations? Do you use any attention-based models for recommendations?
Maybe I can answer that. Not right now, maybe in the longer term, because recommending restaurants or products is really different from recommending, for example, boards on Pinterest. Over there, you can have short-term session recommendations versus long-term recommendations, wherein, for example, you would have particular interests in the longer term, but if you are in a session, you might be looking at something really different from your interests. So in terms of food recommendations, it is not super useful right now. And also because we don't have, I mean, it is difficult to have domain knowledge across different languages, across different countries with culinary preferences and so on. So not right now.
Okay, we are waiting for more questions. You also, Varun, mentioned that you do some intelligent pre-processing. Could you elaborate a little bit more about that?
I'd like to give an example. For example, Singapore is a really tiny country compared to other countries. So most of the restaurants are available to any customer, which results in some chains having a lot of orders like KFC or McDonald's. And these orders cloud over the other restaurants which are not chains. So if we just like have popular in the area or most ordered from or highest rated, then these chains would always be on top.
Mm-hmm.
So if you drill down to a country by country level, analyze stuff like this and somehow weight it. You don't want to negatively penalize it, but still account for this. And I mean, this is just one of the examples, but it could be something like the shilling attack. In that case, you would have to implement some other intelligent pre-processing approaches. So it really depends on the strategy and what country we're deploying an algorithm to.
Okay, thank you. And another thing, as I said, I mean, my questions are a little bit biased because I'm a data scientist myself. So how do you, for personalized recommendations, for example, how do you handle overfeeding and when that happens?
If you,
Yeah, I mean, yeah, there we are trying, like, for example, some of our models, which are post like classification models, we have this issue of having a very small positive class, like for example orders, and having a lot of samples in the negative class, which would be, I don't know, views or something that we shown or clicks. Yeah, there are many. We tried, of course, with a lot of experiments, like also doing undersampling or oversampling, but what we usually do, we use class weights. So this works good. You have
That's really,
in the neural net architecture that I just showed, while creating a latent space, we actually don't mind overfitting because we know the set of vendors that we have on board. And even if we are not able to predict, let's say, embeddings for a new vendor, it would be fine for us, even if we overfit it.
Oh, it's good enough.
Yeah.
For what you're doing. Great.
Vendors are not, I mean, new vendors do come on board, but the amount of vendors that we have right now is super extensive. And if we're able to even overfit it, it's fine for our kind of recommendations.
It's great to hear that because usually as the data scientists, we are so scared of overfitting. It's like, you know, the worst thing that can happen to you and you have to avoid this no matter what. It's just a shame. And to see that, well, in the end, it depends on the circumstances, on the model you are working with.
We suffer more from underfitting.
Yes, the problem is we have this
okay.
one mobile app, right? And we have call them swim lanes, and basically the personalized swim lane recommended from you is one out of many. The others can be new in town or popular or your past orders. So in this one swim lane, the user basically on the screen sees 2 or 3 maximum vendors, you know. So we really want to be showing him something that is valuable for him.
Yeah, sure. That's great to hear that. We have a follow-up question. So it's about hiring. Do you also hire PhD grads for more junior starting positions? Because Anthony says he used neural networks for his PhD.
Yes, exactly. Actually, we do hire PhD positions, people with PhD, and this is considered as an experience. So it's not. I don't think it will be a junior position.
Great to hear that. We have more related to that. Do you have internship opportunities for someone interested in what you do? So with intermediate Python skills, with mathematics background, is that enough?
Actually, with the dish categorization project that we mentioned was made by a internship student, Laman, and she did her master thesis with us. So this was the first time to have someone with an internship on board. I think it is possible to also have other projects, but yeah, feel free to reach out us and see if you find something.
So we should recommend everyone who's interested in the work we are doing just to contact you, your company, and get in touch and see what possibilities and opportunities there are out there.
Yes, yeah, Delivery Hero is one of the few companies that sort of boomed in the Corona times, and
that's really great to hear that.
Have a lot of open positions.
Just one little thing for our audience. We are going to have a poll. I'm going to launch a poll. The poll is anonymous. It's just because we want to know where you're coming from, what is your role in the tech industry, and what's your opinion about this session. And I hope it's a really good one. So please take part in that. We are also in the last 10 minutes. So please ask questions to our very interesting speakers. I see that people are voting in the poll. So again, how do you communicate? You are a recommender system, let's say, or a team. How do you communicate with, let's say, other teams that that you need to interact with? How is this communication?
Yes, well, usually we get requests from our consumers. We call the brands. So for example, I don't know, we have opened a D-Mart. So this is like a supermarkets, online supermarkets only in Asia or Singapore, for example. And they ask for us, okay, we want to show past orders or popular or recommended for you to our users. And then they have requirements that we have to like follow. How like from how many months in history we should take data, like 6 months or 3 months or 1 year, etc. What is the number of items we are going to see on the first page, for example. This is also something really important, and we usually follow these requirements and build recommendations for this consumer. But also when we want to experiment or improve models, so we also collaborate together with the data fridge team that I mentioned, with the analytics, with the tracking team, cross-selling. So I think collaboration is always there.
Yeah, a lot of
It was
communication.
easier when we were, of course, back in the office. Yeah.
So as I understand, when a new customer is coming, you have, I mean, they have their particular, of course, their particular needs and so on. It's not that you offer the model that you have to every customer, but you adapt what you have to the new customers, right?
Yes. Yeah.
For example, a new customer, we wouldn't know about his food preferences. So the only thing we can recommend would be region-specific popular restaurants or restaurants with offers or stuff like that. That would be independent of what the user thinks about food, but just on the entire region level, something like that. But once the user starts ordering stuff, we start getting this data, and then we can have more personalized sort of recommendations, which is why also some platforms like Spotify ask you to choose artists that you like even before you enter the app for the first time, so that they have something to personalize it to.
Like most popular and what is in your region, and
Yeah.
that's already going on. Please, I'm waiting for questions. So another one. How many people work in the area of machine learning neural networks at Delivery Hero versus general data science or analytics?
I mean, I don't know if we can answer that, but there are a lot of teams that work with like machine learning and data science. Some of them, I don't know if many use neural networks, but I think they starting. Yeah, we have like logistics responsible for the delivery and optimizing the delivery. We have data chef, analytics, marketing tech,
logistics, data fridge
BI.
team.
Do you have interaction with those groups as well?
So with some of the groups more close, but with some not much. But we do have like a internal data guild where we every second week we have presentations. We have meetings where one group will present their work, what they're working on, or outcomes, and we try to share knowledge and also reuse like some information on projects. For example, this embeddings that we are most of the teams are trying to build embeddings around either the vendors, either the customers. So we try to share this information within the team. So yeah.
That's really great to have all this knowledge in-house, and you can easily ask them, or they can ask you, whatever. I mean, this is a really great thing. It's really great to be in that environment. Another question, do you use CNNs as well for product images, for example?
Yeah. So one of the use cases that she had listed was product level similarity, I mean, similar products. And for that, we use pre-trained models, Resonate for images, and for text, we use some encoder.
Universal.
So we do use that. Yeah.
So another question, for your recommendation systems, do you attempt to diversify the recommendations to customers so they aren't consistently recommended a narrow range of choices?
We don't specifically test for sort of diversity, but what we try to do is lower the time ranges or adapt dynamically the time ranges that we gather the data. So will also change the recommendations that we are showing. But yeah, for some users, if they don't interact or they always order from the same place, we cannot do actually much. But there are swim lanes, additional swim lanes on top of the recommended for you that are also recommending like something new or trending. So I think, yeah, new vendors, trending vendors, these are covered also in these swim lanes.
Okay. So we are waiting for a couple of questions more from our audience. I also want to remind everybody that we will have another event of Datalift on the November 27th. So you can register via Eventbrite or LinkedIn. So remember to do that. Hopefully we'll have very interesting presentations like we did today. So I have another question. I mean, for both of you, I mean, you were data scientists before joining Delivery Hero. Were your previous experience very useful, or you learned lots of new things while you joined this team?
I mean, I can go. My background was also mostly in like bioinformatics.
I mean, both of you are very experienced. I know a lot and knew a lot before joining Delivery.
Yes, we did work
My
with
question is how much do you think you learned?
Yeah, a lot, especially for me coming from academic background with PhD. I think covering the whole tech stack was also a really good experience. Data engineering, MLOps, I think this we learned here in Delivery Hero, but also specifically focusing on recommender systems and what are the types, what are the models there, and they're a little bit different than the classical machine learning models that are used nowadays, like regression or classification. So yeah, there were a lot of new topics to learn, and still, I guess.
Great, that's never boring, right? So there is a few last questions. So Anthony says he missed how do we get in touch with you? Probably LinkedIn, right?
Yes.
Yeah, LinkedIn, we can.
Yeah.
Try to contact you.
First name, last name @deliveryhero.com. It's our email address.
That's great. And another question, do you have specific methods how you measure the success of recommendations? Do you track this on a regular basis?
Yeah, we do A/B testing most of the time. We do A/B. We try to do some offline evaluation, but mostly by as I said in the beginning, comparing some parameters or tuning parameters from one approach. But then when we want to try completely different algorithm or method, we do A/B testing. Yeah.
Maybe looking at metrics like CVR, MCVR.
Yes, conversion rates. Yeah.
Right. Okay, we are getting close to the end of our session. I really want to thank you, Aleksandra, Varun, for such an interesting presentation and for talking about recommender systems, such a hot topic in data science and also with a very interesting use case. I'll thank everybody who participated here for the interesting questions and for taking part in this. And I hope I see you again on November 27th for the second Datalift again. Have a nice weekend.